Hi, welcome to my video on review of the unit on trig on a circle with 0, center. And as in all my reviews, or most of them except the congruent triangles, this review can be treated as a quiz marked at a 57. So, as in previous ones, on each page, work out each question, pause the video on each page, work out the answers, score your marks on each sheet, and add the total to the bottom. When you get each page done, add up all your marks at a 57, divide your denominator into your numerator, convert it to a decimal, move your decimal 2 places to the right to get your percent, how well you score on a unit trig on a circle with center 0, 0. Here we go. The review. Again, if you wish, pause your video and work out the answers to this page and see what you're going to score. The center is 0 is the center of the circle. This is the x-axis and this is the y-axis. Which point represents the rotation from point A? 130 degrees. This is 90, so F. Negative 300 goes clockwise, so negative 300 is 90, 180, 270, so it would be approximately C. Give yourself a mark each. In which quadrant does the terminal arm of 210 degrees lie? 210 lies in which quadrant? Let's see. Quadrant 1, 2, 3, 4. 210 will be 90, 180, and will be around right here. So that's quadrant 3. Give yourself a mark if you have quadrant 3. State the measure of the reference angle for each rotation. So if you rotate 120 degrees, you go 90 and some more. So that's the rotation of 120. And you draw a terminal arm coming out from 0, 0 origin. And so that's 180 and 60 more. And the reference angle is between the terminal arm and the x-axis. So the reference angle is 60. And a negative 135 is going clockwise. Notice the positive goes counterclockwise. So negative 135 is negative 90. Coming over the far as here, terminal arm goes out through. This rotation is the negative 135. And so that leaves 180, 135, leaves 45 degrees right here. So the reference angle is between the terminal arm and the x-axis. You get 45 degrees. And 330 degree rotation. Start at the initial arm is along here. So it rotates 90, 180, 270, and I'm into here. So it's draw the terminal arm. So that's a 330 degree rotation. So the reference angle to the left is 360 is all the way over. And you take off the 330, so you get a reference angle of 30 degrees. So that's 1 mark each, and total for the page is 6. Okay, hopefully everything is going well. You know what you understand what the unit is about. State the rotation given the reference angle. So notice the reference angle is between the terminal arm and the x-axis 50. So this rotation is 180 is all the way. Take out 50 and I get 130. So the answer for the rotation is 130 degrees. Right here I have a 70 degree reference, so the rotation is 90, 180, so it's a 180 degrees as far as here, plus the 70. So it's 210 degree rotation. And right here we're going the other way, so that's a negative. So all the way around 90, negative 180, negative 270, negative 360. So it's a negative 360 and 30 more. So it's a negative 390 degrees. If you have each of these, give yourself a mark for each one. which one or ones below is not coterminal to 60. So coterminal angles have the same terminal arm, which means coterminal angles are angles that end up in the same quadrant with the same reference angle. Okay, here we go. 240. Let's graph 240. 240 is 90, 180, and that's 240. Then the reference angle, 180, 240, take away 180 is 60. So the reference angle is 60, and that one's okay. And we have a negative 60. Negative 60 is this way. And between the terminal arm and the x-axis is 60 degrees, so that one is okay. 110 is a 90, and there's 110. So you can think about that angle right there. That's 90, and that's 20. That's 110. So that's 20. This is 70. That's one way. Or if we think of this angle as rotating 110, then 180 altogether, so that's 70. So this one is not coterminal. And 330 is 90, 180, 270, right on over. And there's the terminal arm, and that's 330. So that's a 30 degree reference angle. So that one is not. So C and D. If you have C and D, give yourself a mark. Number 6, state two positive rotations, coterminal to 120. If you take 120 and add on 360, you'll get 480. So 480 degrees is coterminal with 120. And if you take the 480 and add on another 360, then you get 840 degrees. So it's another coterminal. And adding on 360, 360, 360, etc. will give you positive coterminal angles. And number 7, state the smallest positive coterminal angle to each, the smallest one, positive one. So if we take 472 and subtract 360, you'll get 100, and that's a 6, 112 degrees. That's the smallest. And if you have a negative 160 and you add on 360, you will get a positive 200. So if you have 112 and you have a 200 degrees, give yourself a mark each, and that's a total of 7 for that page. Hopefully everything is going well. And just to remind you, always try to give a review at the end of each unit that sums it all up, and the review is done in the order of the videos that I have in the unit. Number 8, -3, -4 lies on the terminal arm of theta. Theta is in standard position on the circle with center 0, 0. Find the length of the radius. So let's draw a diagram. And we draw a circle. And the point is -3 and -4. So let's pretend that x is -3 here, -4 for y here. So this is the point on the circle. Don't have to be exact, just rough. So there's the point. So we drop a terminal arm to the x-axis. We drop perpendicular to the x-axis. The rotation for theta is this rotation on the circle all the way around till it gets to that point. There's the rotation. That's theta. So the terminal arm, this arm right here, this arm with the arrow, is rotated right around till it hits, and that arm there is the same as this one, only just rotating around. And then for you have x is -3, y is -4, and we have to do the radius. And the radius can be found, because it's, again, just a review, c squared is a squared plus b squared in a right triangle, whereas c is the radius of the circle, x and y are the a and b's. So the radius is -3 squared plus -4 squared. So r squared is 9 plus 16. R squared is 25. and the square root of r squared is plus minus the square root of 25. So r is plus minus the square root of 5. And the radius is always positive, so the radius is 5. So give yourself 3 marks if you have a 5. If you drew your diagram and label it, you get a mark. If you worked out your radius with the Pythagorean to be here, you get a mark. And the final, just 5 by itself, 3 marks total. Number 9, the terminal arm of alpha passes through the point 12, negative 5. Alpha is in standard position on the circle. Find as a fraction the value of the 6 trig ratios. So, again, I always draw a diagram to represent everything. And here's the circle going around. Again, this is the x-axis and that's the y-axis. And x and y. So x is 12, y is negative 5. So let's just pretend that that point is right there. X is 12, y is negative 5. 12 is over here. And y, negative 5 is here. So the alpha, the rotation is from the initial arm. So you're rotating right around the circle. The initial arm is floating around until it passes out to that point. So that's alpha, that rotation. So we drop a perpendicular to the x-axis, and we have what we call the reference angle right here. This angle that's right in this, between the terminal arm and the x-axis. And x is 12, and y is a negative 5. And so we have to get the radius of the circle. So r squared is x squared plus y squared. R squared, x is 12. Y is negative 5. R squared is 144 plus 25. R squared is 169. Square root of r squared is plus minus the square root of 169. R is plus minus 13. So r is, again, always positive, so r is 13. Now, we want to find as a fraction the 6 trig ratios. Well, we can do cos, the cos of alpha. Cos is the x over the r. So the x is 12, and the r is 13. So since we have cos, let's do secant its reciprocal. SEC, SECANT is 13 over 12. So we just reverse the cos. Sine of alpha. Oh, I got theta here. So used to putting in theta all the time. This is an alpha. We're rotating alpha. This is the rotation. The sine of alpha. Sine is the y over the r. So the y is the negative 5 over the radius is 13. And reciprocal of sine begins with S, so I need a C, CSC, cosecant alpha. Reciprocal is 13 over 5, but the negative goes in the numerator. And we also have tan of alpha. Tan is the y over the x, the opposite over the adjacent, so it's the y, which is negative 5 over the x, which is 12. And the cot of alpha is the reciprocal. Cot is the x over the y, so it's a 12 over 5, and the negative number goes in the bottom. So 12 marks altogether. So you have, if you picked up the radius, you picked up 3 marks. If you picked up each of these, you picked up 1, 2, 3, 4, 5, 6. So 9 altogether. So a total of 12 for that page. Hopefully everything is going well. Number 10. Again, don't forget to pause the video. A point, negative 3, 4, lies on the terminal arm of theta. Find the value as a mixed numeral. Okay, we have negative, let's see, we have the point, negative 3, 4, that lies on the circle. So let's draw a circle. The point x is negative 3, y is 4. X is negative 3, and y is 4. Let's pick that point right there. Don't have, again, as long as you're over, x is positive on this side, x is negative on, x is positive on the right, x is negative on the left, y is positive going up, and y is negative going down. So there's the point, and the rotation. There's the initial arm. So the rotation on the circle is this rotation, and that's theta. And the terminal arm going out to the point is right there. And we drop it perpendicular to the x-axis, never to the y. So x is negative 3, and y is 4. So we work out all the trig ratios. We need the radius, so r squared is x squared plus y squared. And r squared, x is negative 3, y is 4. That's a 12, 16. Notice I'm using similar numbers all the time just to make sure you know what you're doing. And that's what most teachers do. They keep using the same set of numbers. And the radius is positive. So now we have the radius is 5. So now we have to work out each of these. So the cot, cot is the x, or tan is the y over the x, so cot is the x over the y. So cot is the x over the y. So the cot is negative 3 over 4. Sine, again, this is we're picking it all up from the reference angle now. This is the reference angle. So sine is the y over the r, radius. So the y is 4 and the radius is 5. Cos is the x over the r, or the adjacent over hypotenuse. So the x is negative 3 and the radius is 5. And we have plus, we notice we have a secant being squared. So the cos is a negative 3/5, so secant is a negative 5 over 3, just the reciprocal. Now we have them all substituted in, and we do PEMDAS, or bed mass, PEMDAS. So we do the, I'm going to only do one at a time, just to make sure that, so I'm going to do the exponent first. So when we square this, we get a 25 over 9. So the exponent is done. Or, should I say, in the brackets. Oh, let's, excuse me. I got to do inside the parentheses first. So negative 3 over 4. And we add, common denominator is 5. So let's do it right. I have to do inside of the parentheses first. Done. Then I do my exponent. So I have a negative 3/4, 1/5. Now I square it and get 25 over 9. So they're done. Now I do multiplication, division, left to right. So I multiply, and I get a negative 3 over 20 plus 25 over 9. So multiplication, division is done, and then I add and subtract last. So 20 is made up of a 4 times 5, which is 4 times 5, which is 5 times 2 times 2. 9 is made up of 3 and 3. So there's nothing in common. So that means I have to multiply the first one by 9 over 9, the second one by 20 over 20. That gives me a negative 27 over 180. And that gives me 500 over 180. Add, common denominator is 180, and I get a 473. And I said change it to a mixed numeral. So when we divide 180 into 473, I get, that goes by twice, so that's 360. That gives me 113. So it's 2 and 113 over 180. If you This is the fractional form. It can't be reduced because there's no factor. You can try to get the factors out. There's no factor of 180. We'll divide into these to reduce, but I want it as a mixed number. So there's 10 marks. So if you got the radius, you got a mark. If you got each of these correct, you have a mark. If you did your parentheses, you got a mark. If you did your squaring, you got a mark. And if you multiplied, you got a mark. And if you simplified to here, you got a mark. And then if you got the final answer, so 10 altogether. 10 marks if you got 2 and 113 over 180. Let's continue. Number 11, place Q1, Q2, Q3, Q4 in the quadrant. Q1 is quadrant 1, quadrant 2, quadrant 3, quadrant 4. 1, 2, 3, 4, as in the rotation of a 90-180 sector, 1 mark. And which quadrants, state the quadrants where cos is positive. So what I'm going to do is look at add sugar to coffee or to casserole, your choice. Or we can think of, you can also think of cos being with the x. You can think of sine being with the y, and the tan is the y over the x. So add sugar to coffee. If you start with this one, A stands for all, sine, tan, cos. Or you can have the casserole. The only thing about the casserole, casserole starts in quadrant 4 and goes C-A-S-T. And so, or you can think of cos as the x. So cos is negative, cos is positive in 1 and 4, so it's negative in 2 and 3. Sine is positive. Sine is positive in 1 and 2. I always look to find out where they're positives, and then the negatives in the other ones. Tan is negative. Oh, I didn't put any bars there, so let's put a couple of these in. Tan is positive in 1 and 3, therefore it's negative in 2 and 4. If you have each of these right, give yourself a mark. Now, state where, okay, again, write that down. Add sugar to coffee, and that's all, sine, tan, cos. And also note that if sine is positive, then cosecant is positive. If cos is positive, secant is positive. If tan is positive, cot is positive. So where is, and this is the, where is cos negative? Cos is positive in 1 and 4, so it's negative in 2 and 3. Remember, cos is the x. X is negative on this side. Tan is positive, positive in 1 and 3. And which one is mentioned twice? Quadrant 3. Cosecant is the reciprocal of C. Cosecant is the reciprocal of sine. So where's sine negative? Sine is positive in 1 and 2, so it's negative in 3 and 4. Secant is positive. Secant is the reciprocal of cos. So cos is positive in 1 and 4. Which one is repeated twice? Quadrant 4. So quadrant 4, quadrant 3, quadrant 4, mark each. Number 14. Sine is a negative 4 over 5 in quadrant 3. Theta is in standard position on the circle center 0, 0. Find cos. And okay, here we go. We draw a diagram. And again, this is the x, and that's the y. And sine in quadrant 3. So we're in quadrant 3, so the terminal arm will go out in quadrant 3. And we drop a perpendicular to the x-axis. And sine is the y over the r. So the y is negative 4. So the y is negative 4. And the radius is 5. Now we have to work out what x is. So because cos is the x over the r, and the tan is the y over the r. So cot is the x over the y, so I need the x coordinate. So, to get the x coordinate, we have to go with r squared is x squared plus y squared. R is 5, so it's 5 being squared. X we don't know, and the y is -4. So that's 25 equals x squared plus 16. And that means that we have 25 minus 16 equals x squared. And x squared is equal to 9. The plus minus 3 equals the square root of x squared. Oops, now look what I just did. That's plus minus the square root of 9 equals the square root of x squared, and that becomes square root of x squared is x, and that's plus minus 3. And x in this quadrant is negative, so the answer for x is -3. So x is -3 because you're in the third quadrant. X -3 over the radius, which is 5. And cot is x, which is -3 over the y, which is -4. So the cot becomes 3/4. And give yourself a mark each if you have those two figured out. And the total is 8 for that page. And hopefully again, it's the same pattern, just re-emphasizing what the trig, how trig is done. And the tan, again, don't forget to pause your video. The tan is 5/12 for beta. Beta is the standard position on the circle with center 0, 0. And you might say, why am I emphasizing 0, 0? Well, the circle can have a center out in one of the quadrants, but we're not going to entertain that. That's in the higher math. But for all the ones we're doing here, the center is 0, 0. So, how do we do it? Well, we don't know where tan is, so we have to go with add sugar to coffee. All sine tan cos, or the cash flow, C-A-S-T. So tan is positive in 1 and 3. So we have to go in quadrant 1. And we have to go in quadrant 3. So here we are. Draw a circle. Draw another circle. So we're in quadrant 1, which is right here. Draw a terminal arm. Remember, it's rotating up from the initial arm. So there's beta rotating right to here. And we drop a perpendicular to the x-axis. So tan is the y over the x. So the y is 5 and the x is 12. And also we're in quadrant 3. So we drop the beta is all the way around here till we hit this point. So there's the terminal arm. So we drop a perpendicular. So again, the y is, we said 5 and the x is 12. But because we're in quadrant 3, the x is negative and the y is negative. So let's figure out what the radius is in order to get cos. Because cos is the x over the r, so we need the radius. So r squared is x squared plus y squared. And r is, we've got to find it, x is 12. Or x is 5. So 12 squared is 144. 5 squared is 25. R squared is 169. The square root of r squared is plus minus the square root of 169. R is plus or minus 13. So the radius is 13 because the radius is always positive. So notice if we put this one in here, we put a -12 and a -5, but when you square, you still get these same numbers. So the radius, so cos theta is the x over the r. So in this quadrant, cos is the x, which is 12 over 13. And in this quadrant, still x over r, but the x is negative 12 and the radius. So notice the radius is 13 each time positive, but in the first quadrant the x is positive, in the third quadrant the x is negative. So there's the two answers. So 6 marks altogether. If you picked up the right quadrants, 1 and 3, give yourself a mark. If you drew the two diagrams, give yourself a mark each. If you picked up the radius is 13, you give yourself a mark, and if you get the two answers, 2 more marks, 6 altogether. Now we have another one to do. Again, point 1, negative root 3 lies on the terminal arm of alpha. Alpha is in the standard position of center 0, 0 circle. And find alpha on the interval of 0 less than alpha less than 360. That means alpha is between 0 and 360 or equal to 0. So we got to find a positive rotation. So again, draw the graph, put the circle in, and this is the x, this is the y. X is 1 and y is negative. So x is positive, y is negative. So let's say that's a 1 and a negative root 3. Terminal arm goes out through. So alpha is this rotation around here. Oh, just go back to here. Remember, theta is in this rotation in the third quadrant, and oh, theta. I got beta here, theta here. No, they just noticed that. Let's do beta. Sorry about that. Beta is the rotation. Just caught myself. Beta is the rotation. So beta is the rotation to get to the third quadrant here. Beta is the rotation to get to the first quadrant here. So beta, go back, I just noticed it. Didn't notice it before. I was more concerned with explaining. I had beta, should have beta here. This is a beta. Sorry about that. Now, this is going to be correct. We're going to rotate right on around until we get to that fourth quadrant, that point. And this is alpha, right? This is the rotation. So we drop a perpendicular to the x-axis. X is 1, y is a negative 3, and we want to find this rotation. So to get the rotation, we don't need the radius because we have the x and the y. So we have a tan. Alpha is tan is the y over the x. So that's a negative root 3 over 1, which is a negative root 3. So that means we want to find, what we should do is find a reference angle. So alpha is a negative root 3. So but the tan of the reference angle, when I put the reference angle in, I just keep the fraction or the number positive. That means the reference angle is tan to the negative 1 on root 3. So when I do the reference angle and I pick up my calculator, here's the calculator, and I turn the calculator on and I go inverse tan of square root of 3, and my reference angle comes out to be a 60 degrees, dead on, perfect. And so if this is the rotation all the way around, the circle is 360, so alpha is going to be 360. Take off the reference angle. The reference angle of 60 is right there. So this rotation is 360, take away 60. So that's a 300 degree rotation. And again, if you have this, you get 1. If you have the 60 reference, you get 1. If you have 300 degrees, you get 1. 3 altogether, 9 for the page. Okay. And the last question, sum up the last video I did. Find the coordinates of the point on the circle with a radius of 4. The point lies on the terminal arm of 310. Okay, we want to find the coordinates of the point. So what we have a circle, x-axis, y-axis, and we're rotating 310 degrees. Remember, rotating from the initial arm, which is this one. Rotate right around 180, 270, and there's, pretend that's 310 roughly there. So there's the initial arm, right there, rotating right around, and it hits here. And we drop a perpendicular to the x-axis, and again, this is the x, this is the y, and this is the r. So the coordinates of this point is x, y. So the cos of the rotation, the cos of theta, we say theta is the rotation, cos is the x over the r. Therefore, the cos of the rotation 310 degrees is x over the radius of 4. So cross multiply, x equals 4 cosine or cos 110. So x equals 4 cos 310. So we clear the calculator. 4 cos 310. And we get, and I says to the nearest 100, so it's 2.57. 2.57. And the y coordinate is the sine of theta is y over r, and theta is 310 degree rotation, and the y coordinate over radius of 4, cross multiply, y is equal to 4 sine 310, and clear it. We have 4 sine 310. We have a negative 3.06. Again, the 4 is less than 5, so the 6 stays, so there's a negative 3.06. So the point has 2.57, and the y coordinate is 3.06 approximately. Notice that this point, we didn't need the radius of the circle, but this point is made up of the cos theta is x over r. Because we have the rotation, because we have r, we can cross multiply and we'll pick up the values. We didn't need, so because the radius is 4, we can put, that's a 4, 0. And this point, let's go to this point. This point, x is 0, y is 4. This point right here, x is negative 4, y is 0. And this point right here, x is 0, y is negative 4. So the maximum, the radius on this circle, that's a 4. Then we need, and the rotation is 310 degrees, but we're working it out in relation to the reference angle. So we put the 310 in, and the furthest, the largest maximum point on this circle could be 4, and the smallest point, smallest value, when I say point, I mean largest value is 4, the smallest value is negative 4. So notice that these are okay. That's not up to 4, and that's not down to negative 4. So you can see that x is positive on this side, perfect. Y is negative going down, perfect. And the maximum minimum value is 4 to negative 4. And if you have, again, if you worked out these two, you have your point each. If you knew this, so 4 points here, and putting it together, you get 5 points. And go back to the first page, total up your page, and you get a mark out of 57. Divide 57 into your numerator, your total, change it to a decimal, move it 2 places to the right, and you get your percent. And hopefully everything went well. Hopefully you know what I've done in my videos, you'll understand. If you didn't, then review the videos again. Make sure you know, because you need this to go over the unit circle, you need this to go over radians, you need this to go over a graph, you need this to solve trigonometric equations. Very, very important to understand. to do the rest of your trig. Thank you for viewing my video. Bye-bye.